Alright, in this video we're going to look at a quick introduction to continuity, and we're not going to give the we're not going to see the rigorous definition of being continuous using limits yet, but we will see, if we take the first thing as a given, some of the full definitions of later consequences. So working definition, meaning good enough to figure out for most of your pre-calculus and some of your calculus problems, for being continuous at a point is as follows. F of x is continuous at x equals a if and only if you can draw the curve of f of x through a, or through x equals a, without lifting your pencil. Or otherwise noted, basically we're trying to say there are no breaks in the curve, whatever breaks means, at x equals a. Okay, so here are some examples. For a function like f of x equals x squared, or any polynomial, this is continuous at any point. And we can consider its graph. That's a terrible x squared. Let me try this again. And if I consider some point, let's say at x equals, that looks like maybe 1, I can draw this curve through 1 without having to pick up my pencil. However, if I consider a different function, let's say this one, so I'll say, sorry, f of x is continuous at x equals 1. Alright, what if I consider g of x equals x squared plus x all over x? Well, I know that I can reduce this down by factoring out an x and being left with x plus 1 all over x, and I can sort of cancel these x's out, but I have to keep in mind, in this original problem, x cannot equal 0 because that would make this division undefined, so I would have to say that this is equal to x plus 1 so long as x does not equal 0. And that graph looks like this. So it looks like a line except for one thing. At x equals 0, we have a hole. So at this point, 0, 1. So g of x is not continuous at x equals 0 because of this break. If I tried to draw it, and again, yeah, I guess you could say, well, I can go here, then I can do a little loop-de-loop, and then go on. No, that's not what we mean. If I wanted to draw this, I would have to pick up my pencil and start again to get there. However, it's worth noting, so I put however, at all other points, it is. So at x equals 1, well, yeah, that's fine because I can just draw straight through there. So just because there is a break somewhere on the graph doesn't mean that there are no places where it's continuous. So moving on, I'm going to use this working definition to get a few more things. What's it mean to be continuous over an interval? Well, basically that means that a function is continuous at every point in that interval. And so, for instance, let's just do f of x equals x over x. So this is continuous on the interval, open or closed. I'll make it a half open interval from 1 to 3. And you can see that from the graph. This one is just the constant function at 1 everywhere except for where x is equal to 0. And from 1 to 3, including 1 and not including 3, I can draw this without picking up my pencil. This is not continuous on the interval -1 to 1 because it has this break in the graph at 0. Now it is worth noting that something like the floor function, so g of x equals the floor of x, we're going to consider that this is continuous on an interval from, let's say, 1 to 2, even though at the point 2, or sorry, at the point 1, which is included, there is this break. We'll get into more specifics on why we're allowing that when we put on the full definition. Basically, I'm only going to look at this side coming at it from the right because that's sort of inside this interval, but I can draw this entire region without picking up a pencil. That's the idea. However, there are many discontinuities or breaks in this graph. So that should be pretty obvious, pretty self-explanatory. Now, continuous function. And there are two common definitions for continuous function. Check with your teacher to see which one he or she is going by. One definition is to say a function is continuous, or let's say is a continuous function if it is continuous at all x values in its domain. And this one's a little bit strange. The one that most people might prefer is this different one, and depending on who's talking to you, depending on what book you're using, they might follow this one. So a function is continuous, or sorry, let me write this next, sorry, is a continuous function if and only if it is continuous for all real numbers x. And this is the one that you might think of. So here's the difference. This one includes things like polynomials because there's no breaks anywhere. This thing includes exponential functions. And so does this. Okay, this one includes, this sort of x cubed minus x, or this e to the x. But here's where things get a little bit wacky. This one includes things like tangent. And the reason for that is, you're saying, but hold on, there are tons of breaks in this graph, so how can it be a continuous function? Well, each of the breaks in these graphs, in this graph here, happens at points not inside the domain, so tangent. So one of these breaks is at pi over 2. Pi over 2 is not even in the domain of tangent, so we don't worry about it for this continuous function. Like 1 over x has a huge break in it, but at 0. But that's not in its domain, so we don't care. Tangent is not considered, tangent is not considered a continuous function if you take this definition where it's for all real numbers x. And I guess another thing to consider is, so how can we allow all these breaks and have anything that's not a continuous function? When we consider the step function, this is not a continuous function for either case, because in here there are these breaks, let's say x equals 1, and x equals 1 is in the domain of this floor function. So I guess the easiest answer is if you're looking at something like the AP test, GRE test, you're not going to have, I'm assuming you're not going to have a question like, is this a continuous function? Because there are differing definitions of that. A much better question would be, is this function continuous on all values in its domain? Or is this function continuous on all real numbers? And that is a very clear, direct, unambiguous question. Alright, feel free to comment below if you have any questions. I hope this helped you out.